It's a frame. If I shut it up, it sits on the back of the cabinet. And when I mentioned crack on the back of a rack, it is literally crack on the back of a rack. Cabinet. So with the product, the frame comes. The frame's there to take the weight of the door. So the door, fully wet, as in completely populated, is around 1,300 kg. So it can be extremely heavy. But the frame takes the weight, so the buckle doesn't come from the cabinet, the floor doesn't take it, the frame takes the load. We spread the point load, as you can see. I don't know where the hoses have gone, but here, you can all see, typically you'll have a flow and return. So effectively there'll be some silicone pipes, I don't know what they've done with them. Coming off of that, they can either run through the top of the cabinet or through the bottom of the cabinet, depending on the data center. A lot of the new data centers are literally on a slab, so they won't be on raised floor. So they'll be all at the top, all pipework would be across the top, which from a data center perspective, typically when you say put in liquid in a room and putting it above the racks is like a what? But now it's okay, right? It's as long as it's installed correctly, and Usystems have specific companies that we train and test and certify to install our doors. You can't ship a door out to anybody and they can install it. It has to be our certified engineers that install the doors. Reason being, like Andrew, who was here earlier from Usystems, who's gone off, he's off to Korea to watch somebody else install the door and make sure it works. So what happens is they run off onto the main system. There's a couple of things here that you need to notify. I mentioned about how a fan speed can go up and down depending on the load. So you'll have temperature sensors in the cabinet itself. So the heat comes off the back of the servers, hitting the coil. There's thousands of capillaries in there, so it goes all the way around, cools that temperature down, and then spits out the side. So we have what we class as reverse centrifugal fans. What that means is we operate at a lower power density for the fan, but it gives optimal performance. So what that means is you'll see some other rear doors in the industry that have fans sitting here and they're just pumping straight out. By us doing this, ultimately it works in conjunction with each individual rear door as it goes along. So what that means is if I lose, for any reason whatsoever, power to this cabinet, this door fails, my rear door next to it or the rear door to the other side of it will pick up the heat load of the room and give the ultimate ambient temperature to the whole facility. So it's an M+N or an M+1 solution, depending on how you do it. So that's temperatures. We also have a couple of things in there. So you'll see here these valves. So this is called an activator valve, and a ball valve. So the activator valve is based on temperature set points. So as different data centers have different flows from 14 degrees in to 32 degrees out, 26 ambient temperature, etc., etc. Part of our role is we commission the door. So whatever the client says, it's not a cookie cut solution. Every data center is different. So we'll go in and we will set the door up to run at the temperature set points that they deem for the facility. Remember what I said in there when we said about connecting to existing infrastructure. If the existing infrastructure is 18 degrees in, 26 out, ambient temperature of 24, we'll commission this door to run at that. And what that will mean is that door, any variance in temperature, it increases the fan speed from 10%, 20% to 100% to bring the ambient temperature down to the set demand. So theoretically, once this is installed, the engineers and the do not have to come and see anything. It will run itself. It's what we class as an AI cooling capacity, right? It does what it's supposed to do, when it's supposed to do it without a physical intervention. Unless, I shouldn't say this, but we'll say, unless one of these fans fails. So, like anything, they're on bearings. Bearings after a period of time wear down. Nice thing about these is they're hot swappable. So what this will do is it will connect back on a building management system, direct feed to their system, and if it fails, it will show on there that the fan is slowing the capacity, not failed, slowing. So the engineers can come out, pop this panel off, there's 4 screws, they remove the fan and plug it back in while still active. So there's no downtime. We've had it where we've had all fans fail. Yeah. Again, the engineers will come in and just replace it. What else we had? We had anything else? Coils. Coils haven't failed. Coils have leaked where there would have been an incident. As an example, I've seen it where an engineer's been installing servers into there and they've bashed something and it's gone through and it's pierced the coil. It's a pinprick amount. They generally won't see any liquid, but what they will see, you'll see this, which is a pressure sensor. Back at the BMS, they see the pressure drop slowly in that rack, and then they go, what are we going to do? What we do, depending on who's done it, is under warranty. We'll replace the door. 90% of the time, they can carry on running the unit until such time, because it's a pinprick, you're not going to see it. If it's a catastrophic disaster, i.e. these fail, the door will shut down completely. The actuator valve here, I mentioned, can be deemed possible that it completely closes the flow. So there's no liquid going in. So whatever's in there can be drained off. There's a tap-off point, we can drain it completely. We train every engineer on site to be able to do that process. So what I'm trying to say, and there's leak detection cable in here as well, so if it does leak, we'll see it. It's not needed, but it's a nice thing to have. The idea behind this, once we program it, we plug it in, we power it up, we fill it full of liquid, let it run itself. Cambridge University have had them running for 12 years with no maintenance, no replacements, no changing of parts. Touch wood. So it's a very, very, I guess a simplistic solution. Like I keep saying, a crack on the back of the rack is what it is. This is a computer room air handling unit for that cabinet, taking the heat load from that server or the servers and dispersing it into the atmosphere. That's all it is. It's not new technology, but it's definitely technology that the more people, the more industries are looking at wholeheartedly to say, can that deal with 10 kilowatts? But then I can increase that to 100 kilowatts with doing nothing, like not touching a thing.